So to test if a function is even or odd, we plug in a negative x into our f of x. And if we end up with our original function, then our function is even. If we end up with the negation of our original function, then our function is odd. And if neither of those two things happen, then it's neither, right? So our first function is f of x equals negative x to the fifth plus x cubed. So if we were to plug in a negative x into this, we would get negative x to the fifth plus negative x cubed. And when we take the fifth power or the third power of a negative number, it stays negative. So we would throw that negative out in front, and we would say this would turn into a positive x to the fifth, and then we would say minus x cubed. And so then we see that this is the original negation of our function, so this function is odd. Our next function is g of x equals 3x to the fourth plus 2x squared plus 5. If we were to put in a negative x into this, we would get 3 times negative x to the fourth plus 2 times negative x squared plus 5. So we know when we have an even power of a number that's negative, it will stay positive. So then we can say that this is equivalent to 3x to the fourth plus 2x squared plus 5, which is our original function. So then we know that this function is even. Our next function is n of x is equal to 2x squared plus 5x minus 3. If we were to plug in a negative x, we end up getting 2 times negative x squared plus 5 times negative x minus 3. And if we were to simplify this down, we get 2 times x squared minus 5x minus 3. And we can see that this is not our original function, but it's also not the negation of our original function. So this is not even or odd, so it is neither. All right, so evaluating this piecewise function, we have to kind of gauge where our x is. So if we want to say g of negative 4, we need to look at where negative 4 sits in this piecewise function. Well, it is less than negative 1, so we're going to be using this top one. So g of negative 4 is equal to negative 4 times negative 4 plus 2. So negative 4 times negative 4 is 16, plus 2 is going to be 18. So this is going to be equal to 18. Next, we have g of negative 1. And when we look at our x values, we see that negative 1 is included in the second part. So from negative 1 to negative 2 included, we use x squared. So we're going to say negative 1 squared, which is equal to 1. So then this one is equal to 1. For g of 2, we kind of do the same thing. We see that x is included or equal to 2 on x squared. So then we're going to say 2 squared, which that is just equal to 4. So then this one's going to be equal to 4. And continuing that same process for d, we have g of 3. And 3 is greater than 2, so we know that we're going to be using this 5 plus x function. So we could say 5 plus 3, that's going to be equal to 8, so g of 3 is equal to 8.
All right, graphing the piecewise defined function. F of x is equal to the absolute value of x for negative 4 less than or equal to x, less than or equal to 2, and negative x plus 2 for x greater than 2. Scale this down. All right. So we can start plotting some points. So if we do something like do our x, our f of x value. So at negative 4, The absolute value would be 4. Let's do -2. Go to +2. 0, 0, and do 2, 2. So we can at least graph the absolute value portion of it now. So -4, 4. Plot those points, and we're not less than that. So big solid point there. We come up and we are less than or equal to 2 for the absolute value 1. Now we can do the same thing for the next part. So if we plug in 2 there, we'll get -2 plus 2 is equal to 0. So whenever we plug in 2, we get 0. Then we could plug in 4, and we would get -2. We can do one more. Let's do 5, -3. So be an open hole here, 4, -2, 5, -3, and it's greater than -2, so we have an arrow that goes off to infinity. Okay, identify the value and location of any relative maxima or minima of the following functions. It's a little small, so that way we can at least see what we're working with here. Awesome. All right, so relative maximum are at kind of hilltops of the function. So there and there. So looks like both those maximum values are 5. And one's located at -3, the other one's located at 3. So relative maxima is 5 located at x equals -3 and 5 located at x equals 3. Then minima are valleys. So the only one that occurs there is at 0, 0. So relative minima is the y value 0 located at x equals 0. Okay, part B. Do the same thing here. Okay. Again, maxima occur at hilltops, so it looks like that's going to be there. Relative maxima is 2 located at x equals 0. Then for the minima, kind of the sharp ones at either of those points, but local or relative minima is the y value is 0 located at x equals -2 and 0 located at x equals +2. 42. Use interval notation to write the intervals over which the following functions are increasing, decreasing, or constant. So for A, so for increasing, that's whenever we are going up as we are going to the right. So here's a section of increasing, and there's a section of increasing. So it wants it in interval notation. So increasing from negative infinity to -3, union 0, +3. Then let's do where it is decreasing. And that's where we are going down as we're moving to the right. So we have this section and that section. So from -3 to 0, union 3 to +infinity. And it's always moving, so no constants. Part B. Okay, so again, increasing is going up as we're going right. So we have a section here that's increasing and a section there that is increasing. So the x values in which it's increasing will be from -2 to 0, union 2 to infinity. And then decreasing, that's going down as we're moving to the right. So this value is decreasing and these values are decreasing. So, and those x values are from -infinity to -2, union 0 to +2. Part C. Okay, again, for increasing, going up, so we're going to the left. So this chunk right here is increasing. I don't think any other chunk is increasing. So that'll be from -infinity to 0. And then decreasing is going down as we're going to the right. So that chunk is decreasing. And that occurs at the x values from 0, +1. And then constant. I think this is the only one that we had that is a constant. Means it's just a nice horizontal straight line. So const on the interval, or the x value, is 1 to 4. Question 43. Given the functions f of x is equal to x squared minus 5x plus 3, and g of x is equal to 2x minus 1, and h of x is equal to 3 plus the absolute value of the quantity of 2x minus 1. Find and simplify the following. So f plus g of x will be our f of x plus our g of x. And now we can simplify. Part B, g minus f of x will equal our g of x minus our f of x Now we can simplify. Remember to distribute that negative sign. Now we can combine all the like terms and get negative x squared plus 7x minus 4. Part C, f times g of x. So this will equal x squared minus 5x plus 3 times our g of x. So you need to remember to distribute to each one. So 2x cubed minus 10x squared plus 6x minus x squared plus 5x minus 3. Which then simplifies to 2x cubed minus 11x squared plus 11x minus 3. Part D, g divided by h of x. So we have 2x minus 1 over our h of x, 3 plus the absolute value, 2x plus 1. And that is as simple as that one gets. E, g plus h of negative 5. So g plus h negative 5 will equal 2. Anytime I see an x, I'll replace it with -5 plus our h, which will be 3 plus the absolute value, 2, replace it with -5, -1, absolute value. And then we can evaluate that. And the final result should be 3. F, or part F. F divided by g of 3. Should equal, anytime I see an x, I'm going to replace it with 3. So that's our f on top, so it'll be 3 squared minus 5 times 3 plus 3. That's our f, and our g is 2 times 3 minus 1. The top simplifies to -3, and the bottom simplifies to 5. And that is as simple as that fraction gets. Find the difference quotient and simplify for the following functions. And then they give us the difference quotient. So, I'm going to set this up. Anytime I see an x, we're going to replace it with an x plus h. So we get -3 x plus h plus 5 minus, then I'll put this in parentheses, -3x plus 5, all divided by h. See, we can distribute the -3 to both and this negative sign to both respectively. So we will get -3x minus 3h plus 5 plus 3x minus 5, all of that over h. And now we can see some terms will cancel out. So that -3x will cancel out with this positive 3x, that positive 5 with that -5, and that leaves us with -3h on top over h. We can now cancel out our h's, and we get -3, but since we canceled something on the bottom, h cannot equal 0. All right, part B. F of x is equal to 2x squared minus 5x plus 3, still finding the difference quotient. So we'll set that up the same way. Anytime I see an x, I'm going to replace it with an x plus h minus 5x plus h plus 3 minus that original thing, all in parentheses. So it reminds me to distribute the negative. 2x squared minus 5x plus 3. All this is over h. So I'll do this piece by piece. This is actually 2 x plus h, x plus h. We can distribute that -5 to the x minus 5h plus 3, and then we'll get minus 2x squared plus 5x minus 3 all over h. And we can do some simplifications here. So that plus 3 will cancel, or that minus 3 will cancel with the plus 3. This plus 5x will cancel with that minus 5x. And then we'll need to FOIL this component. So we are going to get 2 x squared plus xh plus xh plus h squared minus 5h minus 2x squared, all of that over h. Now we can distribute that 2. Minus 5h minus 2x squared over h, and we'll see that 2x squareds cancel out, leaving us with, and we can combine that 4xh minus 5h, oh, that should have been 2, plus 2h squared all over h. We can factor out h from the top and the bottom. And then we can see that we can cancel those h's out. So we'll be left with 4x plus a little bit of rearranging plus 2h minus 5. But since we canceled out an h in the denominator, h cannot equal 0. Okay, part C, f of x is equal to 3x plus 2, over 3x, 3 over x plus 2. So just the same, we'll have 3. Anytime I see an x, replace it with x plus h plus 2 minus 3 x plus 2 all over h. So looking at this, we have a fraction here and a fraction here and a minus sign. So the only way we're going to get these to interact nicely together is find a common denominator, which will just be this denominator times that denominator. So this one will get an x plus 2, x plus 2, and this one we're going to multiply by x plus 2 plus h over x plus 2 plus h. And then I'm going to rewrite that divided by h in this next step. So we should get 3 x plus 2 over x plus 2 plus h multiplied by x plus 2 minus 3 x plus 2 plus h over x plus 2 plus h, x plus 2. I'm going to say all of that is divided by h. Combine that all into one fraction and distribute the 3 to everything. So we get 3x plus 6 minus 3x plus 6 plus 3h all over our x plus 2 plus h times x plus 2. And this is still all divided by h. We can distribute that negative and see that that is going to cancel out with this is going to cancel out with that, and that's going to leave us with a negative 3h on top, x plus 2 plus h on the bottom, x plus 2 also on the bottom, and we're still dividing by h. So at this point we can cancel out our h's, so we'll be left with negative 3 over x plus 2 plus h multiplied by x plus 2, and we canceled out an h, so h cannot equal 0. (45) Given f of x is equal to 3x squared minus 7x plus 2, and g of x is equal to 2x plus 5, find and simplify the following. G composed of f is equal to, we'll start with the g, but anytime we see an x, we're going to replace it with all of f of x. Plus 2 plus 5. All right. Now I can distribute and simplify. So the simplest form is 6x squared minus 14x plus 9. Part B. F composed of g. We'll take the f function, and anytime we see an x, we'll plug in the g function. So that's how it's set up. Now we get to do the simplifications. 3, this is really 2x plus 5, 2x plus 5. Remember to distribute both the minus sign to each of them. All right. Now we can FOIL. So that'll give us 4x squared plus 10x plus 10x plus 25 minus 14x, and we can simplify just a little there. So we can combine those two terms into 20x, and then we can distribute the 3. And then we combine the like terms, and we'll end up with f composed of g of x, 12x squared plus 46x plus 42.
Okay, so looking at 46 here, we want to be given we're given s of x is equal to x minus 5, and t of x is equal to 1 over x minus 10. Find and simplify the following. So A wants us to do s of t of x. So the way I like to write this is s of t of x. So what we're doing is we're plugging the function t of x into s, right? So s of t of x is going to be equal to 1 over x minus 10 minus 5. So now we want to combine these two into one fraction using our common denominator of x minus 10. So what we want to do here is we want to distribute that 5 to our numerator. So 1 over x minus 10 minus 5x minus 10 over x minus 10. So now they have the same denominator, we can add them together. So s of t of x is equal to 1 minus 5x. That negative is getting distributed, so plus oh, this should be a 50 up here. So plus 50 all over x minus 10. So it means we're going to simplify down to s of t of x is going to be equal to negative 5x plus 51 over x minus 10. All right, so next we'll look at part B. It wants t of s of x. The way I like to write this is t of s of x. Now we know we're going to plug in s of x into our t function. So t of s of x is equal to 1 over x minus 5 minus 10 right? Simplifying this down, we're going to be left with 1 over x minus 15. So that's going to be our answer for t of s of x equal to 1 over x minus 15. Okay, we're at 47 here. Find two functions f of x and g of x such that h of x is equal to f of g of x. So for part A, we're given that h of x is equal to the cubed root of x minus 7, right? So my initial thought is we can see that there's probably a function that's going to be a cubed root of x, right? And probably another one's going to be x minus 7 because it's being put inside of there. So now we got to determine which one's which, right? Well, g is going into f. So that means that our g of x function needs to be our x minus 7, and our f of x is going to be the cubed root of x. So now when we look at part B, we know that h of x is equal to 2x plus 5 squared. So we can kind of see we have an interior function of 2x plus 5. That means that our exterior is going to be that x squared, right? So we're putting g into f, so that means that our g of x is going to be 2x plus 5, and our f of x is going to be an x squared function. Now looking at part C, we're given that h of x is equal to 4 over x minus 2. That x minus 2 is cubed. So we have two possibilities here. So our first one, we can kind of see that we have an x minus 2 as an inside function. So that means that our g of x is going to be x minus 2, leaving our outside function of f of x as 4 over x cubed, right? This is option 1. So option 2 for h of x is equal to 4 over x is 2 cubed. We can take the x minus 2 cubed as our inside function, so make our g of x equal to x minus 2 cubed. That makes our f of x function just 4 over x. So that means we're plugging this whole x minus 2 cubed in for this x down here.
Okay, so I'm going to be working on 48A. So we have a popular website with the cost to download individual songs at $1.49 per song, as well as a one-time coupon for $1 off for first-time visitors. So write a function to represent the cost, X, in dollars for a first-time visitor to purchase X songs. So we know our function is like this, and it costs $1.49 per song, so we multiply the two. Then we subtract off the $1. So for part B, we're asked the sales tax for an online purchase depends on the location and customer. If the sales tax rate on a purchase is 6%, write a function to represent the cost T of A for a first-time visitor who buys $A in songs. So T of A. So if our sales tax rate is 6%, that means we're increasing by 6%. So T of A is just going to equal 1.06 times A. So we add that 1 right here, so that way we actually increase if we multiply it. So now for C, find T of c of x and interpret the meaning in context. So what t of c of x is going to be is where we basically replace this a here with our cost function here. So we're going to have t of c of x, it's going to equal 1.06 times our cost of 1.49 x minus 1. So now if we go ahead and distribute that out, what we end up getting is that t of x is going to equal, we'll have 1.5794 x, and then minus 1.06. So, and interpret the meaning in context. So this is the total cost for a first-time visitor to purchase X amount of songs. And then right after that, we're going to evaluate this at 10 and interpret the meaning. So what this means is that we're buying 10 songs, and that's going to be our total cost. So if we plug that in here for t, on this last one here, I was supposed to put t of c of x, sorry about that. So evaluate t of c of 10 and interpret the meaning in context. So t of c of 10 is just going to equal that previous thing where we plug in 10, is we're going to have 1.5794 times 10, then minus 1.06. And if we plug that in, we should get 1473, which means that the total cost to buy 10 songs is 1473. Okay, so 49. Given the quadratic function in vertex form, find the following. So whether the graph opens up or down. So to do that, we look at this number here. And if it's positive, that means it opens up. So we open up. Opens up. So for the vertex, since this is vertex form, this here, the negative of that is our x-coordinate, and this here is our y-coordinate for the vertex. So our vertex is -5, -8. The y-intercept is going to be where we say x is 0. So if we plug in x is 0, we're going to have f of 0 equals 2 times 5 squared minus 8. So that's going to be 50 minus 8 is 42. So our y-intercept is at 0, 42. The x-intercept is where we set y equal to 0 or f of x equal to 0. So we're going to have 0 equals 2 times x plus 5 squared minus 8. And then if we go ahead and solve this here, we can go ahead and add 8 and divide by 2. So we get 4 equals x plus 5 squared. And then we can take the square root of that, and we get that 2, plus or minus 2 equals x plus 5. Again, whenever you take the square root, you have to include a positive or a negative version. And then from here, we know that we have two cases. One where x is going to equal -7, and one where x is going to equal -3. So that means that we have two x-intercepts. One of them is -7, 0. Then the other one is -3, 0. So the minimum value, that's just going to be this location here of our vertex. And the reason why it's going to be minimum is because our function opens up. So that means that our minimum value of the function is going to be -8. So then the x-axis of symmetry is just going to be your location here for your x. of the vertex, so x is going to equal -5, because if we think about a parabola, it opens along that vertex, so it's going to fold along that vertex and be symmetric as well. So the domain of the function, so there's nothing that's going to prevent us from getting a non-real answer or any undefined spots, which means that our domain is all real numbers, or we can say -infinity to +infinity. And then the range, so if we know our minimum is -8, and no matter what we plug in here, this is going to end up getting a pretty big number and going towards infinity. So that means that our range for the function is going to be -8. And we include it because the vertex is a point on the graph, so we use brackets to show it's included, to infinity.